Today we are going to dive into one of the most fundamental concepts in coding, Python data types. Think of these as the building blocks for everything we'll create. At its core, a data type classifies the kind of value a variable holds. This is crucial because it defines which operations are valid. For example, you can multiply numbers, but multiplying words doesn't always make sense in every context. Understanding these types helps us prevent logic errors before they even happen. Let's take a look at the common types we'll be working with. We have int for whole numbers, float for decimals, str or strings for text, and bool for Boolean values, which are simply true or false. We'll be exploring each of these in detail throughout our lesson. Building on what we just covered regarding variables, let's dive into one of Python's most flexible features. Dynamic typing. In many programming languages, you have to explicitly declare a variable's type, like saying this must be an integer. In Python, however, the type is inferred. This means Python looks at the value you assign and figures out the type for you automatically. This leads to flexible reassignment. Because the variable isn't locked into a specific type, you can change the data it holds at any point in your script. Look at this example code here. Initially, x holds the number 10, but then is reassigned to the word 10. Python manages this transition seamlessly. Now, since variables can change types, you might occasionally lose track. That's where the type function comes in. You can use it to inspect any object's classification and see exactly what Python thinks it is. Integers, or int as Python refers to them. An integer is simply a whole number. It can be positive, negative, or zero. A standout feature of Python 3 is that it handles arbitrary precision. This means there is no practical limit to how large an integer can be, as long as your computer has the memory to store it. As this note indicates, you don't have to worry about overflow errors when calculating massive numbers. Python manages that complexity behind the scenes for you, which is a huge relief for developers. Look at these examples. When we assign 30 to number of stunners or 0 to items left, Python recognizes these as integers. These are ideal for counting, indexing, or any scenario where fractional values aren't needed. Keep in mind that as soon as you add a decimal point, the type changes. We'll explore that next when we look at floating point numbers. Building on what we just covered regarding integers, let's dive into floating point numbers, or floats as we call them in Python. Floats represent real numbers, essentially any value that includes a decimal point. We use these whenever precision is necessary, such as for prices, scientific constants, or physical measurements. Think of them as the more detailed siblings of integers, allowing us to handle fractional parts of a whole in these examples. Variables like pyvalue and dit are stored as floats because they contain decimal information. Notice how even a negative balance like 150.75 follows this same rule. Here is a crucial reminder: the value 7.0 is treated as a float. Even though there is no fractional part, that decimal point signals to Python that this should be handled using floating point logic. Next, we'll see how this works in practice in our variable lab. Now that we've experimented with variables in the lab, let's dive into our first text-based data type, the string denoted as string in Python. At its core, a string is an immutable sequence of characters. You create them by wrapping your text in either single or double quotes. It's important to note that strings aren't just for letters. They can contain numbers and symbols too, like a serial number or a complex password. Python allows us to manipulate these strings using operators you usually associate with math, but here they perform string operations. First is concatenation. By using the plus operator, we can join two strings together. As you see here, hi and an exclamation mark become a single hi string. Next is repetition. Using the asterisk or multiplication sign, we can repeat a string a specific number of times. Multiplying hi by 3 gives us hi hi he. This is a very efficient way to handle repeated text patterns. Think about why we might store a zip code as a string instead of an integer, even though it's made of numbers. Let's discuss that briefly before we move on to Boolean logic. Building on what we just covered with strings, let's dive into the most binary form of data in Python, the Boolean type. This is the heart of logic and decision making in your code. A Boolean or bool represents only two possible values, true or false. It is crucial to remember that in Python, these keywords must always be capitalized. These values are the foundation for how a program decides which path to take when we start looking at loops and conditional statements. We usually generate booleans using comparison operators, for example, using the double equal sign to check equality or the greater than and less than signs to compare values. These operations act like questions that Python answers with either a true or a false. Look at this evaluation here. If we have a variable x assigned to 10 and y assigned to 5, the expression x is greater than y evaluate true. Building directly on our discussion about data types, we hit a very common hurdle in Python known as the input challenge. As we just covered, strings and integers are handled differently. A vital rule to remember is that the input function always returns data as a string, no matter what the user actually types in. This creates a problem. A theory in Python, you cannot perform mathematical operations between a string and a number. Look at this example. If the user enters 25, Python stores it as the text 25. When the code tries to add 10 to it, the program crashes because it doesn't know how to add a number to a piece of text. The solution is typecasting. We must explicitly tell Python to convert that input string into an integer or a float before doing any math. We'll look at the specific functions for this in the next section. Building on what we just covered with the input function, typecasting allows us to manually convert one data type into another to suit our needs. The int and float functions are your primary tools for numeric conversion. Just remember that the int function truncates decimals. It essentially just chops the end off rather than rounding on the flip side. The straight function turns any value into text. This is incredibly useful when you want to combine numbers with strings to create a clear, readable message for the user. But a word of caution, if the string doesn't actually look like a number, for example, the word hello Python will throw a error and the program will crash.